Yeah, that's okay. All right, so you have got the Falco hub in your hand, and you have got the spokes. Okay, tell me about what you got.
We have drive side at 169, non-drive at 171mm, and we have our 14 gauge nipples, 2mm diameter thread, etc., and nipple driver.
Okay.
So, we also have our rim of choice, which is 36 hole, dimpled, double skinned alloy rim with rim brake surface, obviously used for disc or rim brake.
So this is a special team hybrid rim.
Correct.
Okay.
All available online. Cool. So, obviously, building a wheel, everything needs to be to hand. So we start off with the hub. We want to aim to have logos at the top and the bottom in line with your valve hole once you've finished the wheel. So the first spokes you get is grab a set of 9 drive side spokes, and they're going from the outside of the hub towards the floor. So we pick our first hole, and in this case we need to be 2 off the logo to allow it to line up as close as possible to the valve hole, and then from that point you just fire them through every other hole. So it's our first round ready to go. So again, find your first spoke you're going to be working with, just get that one so you know where it is, let the rest drop through, and then it's just a matter of hold the wheel like that, or the hub like that, find your valve hole, and make sure your writing's round the right way on the rim.
So can you point to the valve hole? Where is it?
So the valve hole is that hole there.
Okay.
So as you build the wheel, you actually twist the motor in the opposite direction of travel to generate the crossing pattern in the spokes. As you do that, you're then realigning the logo with the valve hole. So if we have it from this position here, that will be the end position, but that's how it will actually start, slightly off centre. So anyway, at this point we've got our first spoke in, so we can now relax a little bit and let the hub just dangle. It's important at this stage not to let the hub turn around, you turn the rim round and then start building away, because you'll have the spokes coming out of the dimples in the wrong direction, which basically equals snap spokes or snap nipples. It's just too much stress. So from this point, you got your first one in. That's basically the most important spoke of the wheel to get right. Once you've done that, everything else will just follow through counting numbers and counting the right amount of spokes. So obviously on the hub, you're using, at the moment, every spoke you've got, but you're using every 4th hole on the rim. So obviously you don't count the first one, but 1, 2, 3, 4, that's where your spoke's going to go through. Just fire that through, wind a nipple onto the end. You don't need to wind it all the way down at this stage, just so that you can see that you've got roughly equal length of thread still showing. That way it means that when you actually get to the stage of tensioning the wheel, you're not having half the wheel done really, really tight, the other half being slack, and you've got a rim which is going all over the place. It just allows you to build the wheel as true and as round as possible from the word get-go. So, got your second one in, rotate it round, grab your next spoke, 4 holes along, up, in, and screw on. And again, just follow the routine. I find it easier to support the wheel by the spokes as I'm building.
So between spokes, you have got how many empty holes? 3?
3 empty holes.
Okay.
And again, as I say, I'll support it by the spoke when I'm doing this, because it just makes it easier to get it into the rim. As you can see, it all just drops back down in. Apart from you've got sweaty hands. Yes, yeah. Sometimes if you can't lift up the hub, you can just rotate it, so that you then allow the slack part of the wheel easy access to the spoke there. It does just depend really on your preference. As I say, I tend to go with the lift up there. And then last one on that round. That's your first side of spokes in. So basically from this point on you don't really have to hold the weight on there too much, you've got everything in situ, and your wheel will look something like that. So obviously at the moment all the spokes are radial simply because we've not introduced a twist to it yet. So from this stage, if you have the wheel as you were lacing it up, so drive side's facing towards the builder, you then turn the rim round 180 degrees so that you're now facing the drive side. Lay the hub down flat so it's on your laps again. And on these ones, because of the nature of the dimples, you'd normally go first hole to the right, but because you're using dimpled rims it needs to be the first hole to the left of each spoke. Even though obviously your first hole, your first spoke on the drive side has to be that one there, at this stage it doesn't matter which spoke you use as reference point because you're always going to the left of the nearest spoke that's on that side. So you find your first spoke there, and again after that you just fire them through every other hole, and again you're still going from the outside of the hub towards the floor. Cool. So let them drop down, wheel back up into position, and again obviously you're going from the hole on the right, or the hole of the left on the hub to the first hole nearest the spoke on the left at the rim as well, and then wind it on, and you've got your first spoke of the non-drive side lined up in there. So again we just follow the same pattern. Every fourth hole you put a spoke in, wind that down, same on there, wind that down, and next one. What's the dog eating?
Hippo.
Rakesh, can you do me a favour and just check that charger on the floor? I don't know whether Pippa was getting too close to it because it was making a frazzling sound.
Still good.
No, the one underneath the sus rear end there. Sorry, I'll let it take you off the work in hand.
Which one?
It's underneath the sus rear end. It's a lithium charger.
Oh, this one.
Yeah, I might be just unplugging it. Oh no, it's still light, that's right. Cool. Anyhow. Dog health and safety.
Better them than me.
Okay, that's the last one of that round. Cool. So, you've done the round on both sides now, so you've got your inbound spokes sorted out on both sides. So now you're still with the drive side, the non-drive side, beg your pardon, of the hub facing the builder, but you're now using your drive side spokes, and you're now aiming through the drive side flange, and obviously there's only one hole, or one set of holes you can use on the drive side flange now, and you're going from what is effectively the inside of that flange towards the outside of the hub. Just drops down. Again, sometimes it's worth just supporting the rim rather than the hub, so you can just fire these through nice and easily. And this is when, of course, you find out whether you've counted enough spokes, which we have. Wonderful. So, from that position, you want to be going to the drive side. So now what you've got on the drive side, you've got your inbound spokes laced into the rim, your outbound spokes are now hanging on the outside of the hub. So what we've got to do at this stage is generate the first crossing of the spokes. So again, it doesn't matter where you start, I'm just going to pick the closest one to hand, and when you go to make the cross, to gain more stiffness in the build, you go from, okay, so sorry Rakesh, I'll get you around the side. You're on the outside, you go through there to the inside, round the back of that spoke, and you're going to the second hole available. nipple in the top, nipple driver, and this is probably one of the harder parts of the build because obviously you've got a lot of weight on there. So nipple driver in the top there, spoke in the bottom, wind it on, and there's your first cross. And at this stage you can see how accurate you are with getting the valve hole and everything to line up. So there's your HX logo. With the rest of the spokes in there, that'll be more or less perfectly in line with the valve hole. And likewise you'll have your Falco logo in line with the join of the rim there as well. Normally you'd have the sticker on the join, partly so you hide the join, and partly again so it just keeps the symmetry going basically. But it's not important to have that, but it's just another aesthetic you can get sorted out. So once you've got your first one in crossed, if you work clockwise around the hub in joining in the spokes, you'll find it much easier to get the next one in without having that spoke in the way. It just gives you a little bit more freedom of movement. And again, if you're doing more than one cross as well, it definitely is an advantage just to go away from that first one just to make life easier. So again, outbound spoke goes through the gap, round the back, second hole along. So effectively on the same drive side you've got a hole in between each drive side spoke, which is obviously meant for the non-drive. So again, tool in there just to keep the nipple from moving. Offer up your spoke. As soon as it's in there you can offer it up and just give it a few turns to wind it in. So if we just carry on going around like that, this is where having thinner gauge spokes also becomes an advantage, because you can get it through smaller gaps and just give them a much gentler bend without then, when you finish the wheel, having loads of kinked spokes that just look ugly as hell. That's the last one on that side. Oops, excuse me. Cool. So that's all your drive side spokes in situ, crossed, ready to be tensioned. We've now just got to finish off the non-drive side. So to do the non-drive side up, 171mm spokes, and again you just fire them through the non-drive flange towards the floor, giving you your outbound spokes. Cool. So then obviously you move the wheel over so that you've got the drive side facing you, and again it's not important where you start crossing over the spokes, but it's just now you've got the double complication of having to get through those as well. So obviously just a gentle bend there behind the initial non-drive side spoke, and then you just need to tweak it through there, again trying to avoid obviously marking the rim. Obviously if it's a new wheel you don't want your customer's wheel to have marks on there, and then it's just again a case of firing through the nipple, give it just a little bit of tension there, and again this time because you're crossing in the opposite direction you lace the spokes up in an anti-clockwise direction. So up, through, round the back, pull it through, and of course now you've only got one hole to aim for anyway, so it becomes a little bit easier as far as that goes. So let's just
Maybe you should explain why 14 gauge spokes are just as good as or better than the thicker spoke.
Yeah, I mean, basically the reason we go with 14 gauge is, one, you get the flexibility in build. If you snap a spoke anywhere in the world, you're guaranteed more or less to be able to get a 14 gauge spoke. Certainly a plain gauge, which is what we're using here, is fairly universal. The other advantage as well is that when you start building wheels with thicker spokes, even going up to a 13 gauge at 2.3mm, just the rigidity in the spoke, without having any tension in it, it's a much thicker spoke to bend. So when you're having it under tensile stress, although in theory it should be stronger, you're not actually able to pull that spoke into as much tension because you can't physically get enough strength in the nipple and the tool to use to wind it in enough to make it worthwhile. So what you'll find is that after a very short space of time, unless you've had an awful lot of tension put into that, which generally speaking the rims and the hubs won't be able to take, the spokes will vibrate loose. Within a few months, if you've done high mileage, they'll just be as loose as that, and they'll start snapping essentially. Even as much as with the 10 gauge spokes we've had in some of our wheels that we've bought from Chinese companies. Again, it's not just them that use them, but they were the company that we had. The wheel feels nice and tight, very, very rigid, but then within the space of 20 miles we've had a spoke that's rattled so loose that it's come out of the rim and is just flapping around the wheel. And of course, when you actually bend or try and move one of these spokes out of the rim and the hub, it's as hard as trying to flex it when it's in the rim. And it's a radial spoke, but the reason it feels so hard when it's in the rim is purely because of the actual thickness of that spoke rather than the tension you've got in your wheel. So with a 14 gauge, rather than having a very strong individual spoke that under no load is pretty strong, you've got 36 very nice flexible cushioning spokes which will stretch and move and allow comfort as well as stiffness, that you can tell straight away are tensioned, are not loose. And obviously these, you'll get spokes like this in the wheel after 6 months if it's not built properly with whatever thickness spokes you get, but obviously this is just the build-up stage at the moment. We've built in the past 5 to 10 kilowatt hub motor builds with radial spokes, 14 gauge, and we've never had any issues with spoke snapping, provided you put sufficient tension in and you're not trying to shortcut a build by just not tensioning it correctly or finishing it off properly. So as long as you use the right stuff, obviously if you're on a motorbike you wouldn't use 14 gauge spokes because the bike weighs at least 100 kilos to start with, you've got several horsepower plus a pound torque as well through there. But most importantly, you've got a rim which is designed for thicker spokes and a hub that's designed for thicker spokes. Therefore, you have tools designed for thicker spokes and you can put adequate tension in those spokes to support a vehicle of that mass. Whereas on a bike, let's face it, you're never going to be that heavy. If you are, you should probably think about using motorbike rims and hubs and have an e-bike system that is suitable for that purpose. But obviously for what we use the hubs and the rims for, there's no need to go any thicker, realistically. This just doesn't seem to be worthwhile, to be honest.
Alright, so 14 gauge in this case is the best choice.
Correct, yeah.
Okay.
So, anyway, we've got the wheel built up, laced. Obviously, it's not under tension at the moment. It'll be hideous to ride, as you can imagine. But at this stage we can check how accurate our lacing has been. So the valve hole is where my finger is and the logo is ever so slightly out of sync, but given where the spoke holes are on the hub flange, that's probably as close as you're going to get. If you'd gone to that one and twisted it round further, you would have missed it by the same increment on the other side. So that's pretty much as good as you can get realistically with the components in use. So once you've got a tyre on there with all the logos and such, it should line up nice and squarely. And again, on the rim sticker as well, it's in the direction of travel, which is going to be that direction, and you've got the majority of the writing you need to read facing the rider on the drive side. Again, little details which will then make it easier for people to read what's going on with their wheel when they need to inspect for maintenance purposes. So, once you've got all your spokes in and you've double checked that your handiwork's all good, we lay it flat again. I tend to have it on the drive side just because it's easier really, well, more for myself than anything. And what we're going to do now is go round and wind down all the spoke nipples so that they're at the end of the thread, and then that will give us a nice benchmark to find out whether our spoke length one is accurate and whether we've built it properly in the first place. So we just go around, wind that down. Now the only thing that you'll find at this stage if you've been cutting spokes to fit a rim is that if you've not wound all the threads evenly, or you've perhaps had a slip with the machine and you've got one or two odd length spokes, you may find that some will be particularly slacker or more tensioned than others by the time you've gone round, but the idea obviously is to have them as equal as possible so that hopefully the wheel will be as straight as it can possibly be before you start tensioning and truing. And this is really where the nipple winder obviously comes into its own, so you don't have to have a screwdriver and do a twisting action, so it saves you a load of tendon wear.
Aren't there automated screwdrivers available which can be used?
You could probably make something up. Basically the tip of the tool has a little step ridge on there in that direction, and in that direction obviously you've got it all quality the way there. So yeah, if you made a tool shape that shape to fit in a drill bit, yes, you could just buzz them in and it would be absolutely fine. The only downside you have on that basis if you're building a wheel by hand is that you don't have a guarantee that you've got equal tension on all the spokes. So with that tool you can feel exactly what's going on with the spoke, whether you've got a bad thread either on the nipple or the spoke itself, or whether you've simply come to the end of the available thread that you've actually got on any given spoke. Obviously when you get to the point where you are starting to get a lot of tension, or you're starting to introduce tension into the wheel, you can then very easily feel that you've got it even and that you're not suddenly coming up against a really massive tight spot. So although yes, if you know that all your measurements are correct, all your rims and everything are fine, then yes, if you're building tens of these a day, then of course something like that would be a fine thing to do. But if you're doing it one or two at a time, generally speaking, although it may save you a couple of minutes, I'd say stick with one of these because it will let you find faults much easier than if you just power it on with a drill basically. But yes, it's a perfectly workable solution if that's what you need to actually be doing with it. That's no problem at all. So at the moment there's still a little bit of slack in the spokes, even though they're all even on there, so we're going to do a couple more winds on each one just to bring it in for the final amount. If we still find that it's a little bit long there, we can obviously trim it down for the next time round and just readjust our measurements at that point. So on the valve files, do a couple more turns of all of these and we should be good to go. And obviously when I'm doing the full rounds on here, rather than just picking a spoke at random and starting from there, either start at the valve hole or the join in the rim so that you've got a clear marker that you've gone a full circle without overlapping any and doubling up on some. So yeah, it may well be that on these we might just need to adjust our measurement. Probably slightly different to the rims we had last time, but that's no bother. Then having said that, this is again part of the reason why having different nipples is a pain in the bum as well, because they're not the standard nipples which come with the spokes. If there's a difference in the way that they make them, it will again adjust. You'll need to adjust the length of the spoke accordingly as well, so it may well just be that. We'll see when we get to the end. I just feel the tension starting to come in. That should be fine. Excuse me.
So how much tension really is good for the wheel? How do you know?
A lot of experience, and again, because I build a lot of wheels that I use myself, you can very quickly gauge. You know, if you ride your own wheels a lot, you can very easily say, well, okay, I'll put this much tension in that wheel. I've broken it. I need to either put more or less in. You can buy spoke tensiometers, which are very accurate and absolutely fine. And obviously, you can then you can buy spoke and rim charts, which will tell you how much tension you should have in any given wheel. The problem with e-bike hub motor wheels is that, generally speaking, there's not enough spoke available for the tensiometer to actually measure the tension in it. You simply can't get the tool in the wheel. So as far as we go with ours, it is purely down to experience and knowing the way it should feel. So when we're actually finished on a wheel like this, you have virtually no spoke movement at all. When you can put a full handful of pressure on the crossing part there, and you should have virtually no movement in that at all, which basically means that when the hub is under power, or if you're using a disc brake, you're going to have very little motion from the spoke against the rim, because obviously the rim wants to stop, but well, the hub wants to stop, but the rim's still attached to the ground via the tyre, so that's still wanting to turn. So it minimises that rubbing, movement at the head of the spoke and movement at the nipple as well. So where possible, you always want to have as much tension as you can have in the wheel, provided you're not overstressing the rim, in which case the rim will fold in unnatural positions. Even though you're only doing small adjustments to it, it just simply can't hold the tension in, so it will just squirm and twist and do horrible things. So it is a bit of a fine line, but again, as I say, experience really is the main one with that. But with 26-inch rims like this, and the fact that you've got such a small distance from the flange of the hub to the rim surface itself, the deflection due to over-tensioning isn't as severe as you would normally expect it to be in a traditional 26-inch wheel. Certainly when you get down to the smaller wheels like the 24 inches and the 20 inches, it's so difficult to get enough tension in the spoke to actually achieve that goal. And again, because it's such a small distance from the hub flange to the rim, you know, you can pretty much crank them up until you start snapping the nipples, and you'll have a wheel that'll be fine, but you just can't true it afterwards. So that really, in that situation, is the limit of to how much tension you can physically put in. Is when you start damaging the spoke nipples by you tightening it and it's snapping the brass, you know you've obviously reached the maximum possible tension due to the components. So at that point, it's either, well, you've either got to take out the spoke that you've now damaged the nipple on so that you can true it at a later date, or you leave it in there if it's your own wheel and you just live with it and have a bit of brass rattling around one of the spokes in the wheel. But that now is an adequate tension to start the building process. Again, you'll notice straight away that there's more tension on the drive side already than there is on the non-drive side, which shows that the lengths that we've used are accurate. And what you should also see from that view there, which is correct, is the rim is already closer to the line of the drive side flange than the non-drive side flange. At the moment we haven't put the axle space on the rim, which we use to space it to 135mm to give you the full effect of the central aspect of the rim, but that's a good indication that you've at least put the right spokes on the right side of the hub. Obviously if you're finding at this point that with that minimum amount of tension that the rim is coming over to the drive side, you've either put far too many winds on the non-drive side spokes, or you've put the wrong spokes on the wrong side. You then slap yourself on the head and curse a little bit, but otherwise you've just got to rebuild it again. There's no way you can over adjust it to go the other way if that was the case. But No, that looks like it's good. And again, you can just give yourself a little spin just to see roughly how, oops, if I can actually hold it straight is always a good thing, but roughly see that it's, you know, it's pretty straight, it's not wobbling all over the place other than the fact I can't hold it. So you're basically now ready to start putting some pre-tension in, get it true, and get ready to ride.
Okay, so let's go through it.
Cool, let's go.
All right, so what is the truing stand is set up for certain distance?
No, basically you can completely adjust both the width of the hub depending on what you're using it for, obviously width of the rim and the diameter of the rim as well. Obviously the width part there is also down to how buckled the wheel is as it's spinning round. Obviously you want it wider for the more buckled it is. So to start with, you set it up generally wider and bigger than you're going to need it, so that you can just plonk the wheel in without too much fuss. I'm just looking for an axle swasher so I can tighten this down in the stand. We shall do. Wonderful. Perfect. Okay, so obviously for our purposes with the Falco hub, we have a side exit cable system. So when we put it in the stand, we want to have the cable facing up so there's no pressure on that as you're building the wheel and truing the rest of it. On the non-drive side, on the drive side, we now have our axle spacer, which sets the motor up for 135mm from flat to flat, which is the standard rear wheel width for most mountain bikes and most hybrid bikes as well. Obviously if you're using it on a road bike, typically you can get a 130mm, some go down to 127.5, but for most customers who are going to be using this system, 135 is pretty much the norm really. So once you actually offer it up to the stand, again, work as if you're behind the bike. So drive side on your right hand side as it would be on the bike, non-drive side on the left. So it's now resting with the cable at the top, coming out there, so there's no stress on that component whatsoever. And on the drive side, obviously you can see there's still a gap there where the stanchions are too wide. So we now wind those down, and that's now holding the wheel in situ. Now because it's a direct drive motor, if you spin it up quite quickly it can generate some back EMF, which will then spin the axle out of the truing stand, which will then move the rim position across your calipers there, and you've got to reset again. So what I tend to do is use a nut and a washer on one side of the axle, just wind that down, and although when you actually tighten this up, if I have my spanner handy, it always helps. So it's a 17mm nut, so even though as I tighten this down it probably will move the wheel, it will be the same every time I tighten it up, and it will still be a known distance. So you're always only just working off one side. You're never going to get a rim that has perfectly mated sides. So generally speaking, you go by a best average, and that will give you a pretty straight wheel. So at the moment, we can just show you what it looks like without any massive tension in the wheels. It's straight from our winding exercise. So you can see there's a little bit of an up and down buckle there, and a fairly sizable side to side. So we can now bring in the calipers there and just gauge roughly the condition of the wheel for a start point. So there you can see it's at the widest part, and that's where we start our truing exercise from. So basically you find the worst area and you adjust that particular section 1 or 2 spokes at a time. At this stage you can be a little bit more ham-fisted with how much adjustment you make in one go, and again through experience you know roughly what you need to do to generate a certain response out of the wheel. So on this particular case you can go by a bit of feel as well. Obviously that is the peak of the buckle right there, and again you want to find as close to the middle as possible so you're at the epicenter of it. And if you're not sure which spokes to tighten, give each side a squeeze, and if you can see there, give those a squeeze, the caliper's stressing out even more. Give these ones a squeeze, it's going to pull it away from that caliper, bringing it back into a central position. So you know straight away that they're the 2 spokes you just want to put a small amount of tension on just to start balancing out some of the waviness. So because of the size of the nipple on these ones, which aren't a standard spoke nipple because of our rim, we have to use the multi fit spoke key which has 6 different sizes on there. We're on a size 12. So slide that over and we just give it a full rotation on each one of those two, which isn't a lot and it hasn't had a massive effect on it, but like I say, you don't want to go too overboard at the beginning because you'll then end up, you know, half an hour down the line going, why have I got a massive dent and a massive buckle in this section of the rim when everything else around it is so slack and horrible. So it's just go steady, go slow, and just work from the worst bit out. And again, every time you do an adjustment,
Alright, so which spokes are you adjusting now?
I'm doing the drive side again just to bring them away from that caliper there. So again, I'm just doing another full rotation on those two, which are basically at the middle. On this spoke here, there's absolutely no tension at all, so I'm just going to do an extra turn just to get it a little bit ahead of the curve. So again, as soon as you've made an adjustment, spin the wheel, see what improvement or worsening of the wheel you've actually generated. So straight away you can see that's got much truer than it was before, and that's made by 4 small adjustments of the spokes. So at this stage, with the least amount of tension possible, you want to get it as round and as true as possible, so that as you move forward you've got a good solid basis to start from. Once you've got it true and round, you then want to check the dish to make sure it is central over the axle, and in that way you can, you know, put your final tensions in there, tensions into the spokes without having to think, oh, I've now got to readjust the whole wheel across because you haven't dished it centrally from the beginning. So from this point, I'm just going to do another quick check on there. We've got a bit of a buckle coming towards the drive side here. So I'm just going to do the non-drive side spokes, a turn there, and the same again there. And again, just check what difference it's made. So it's now made slightly less of a buckle away from the drive side, away from the non-drive, but it's also put a little bit too much tension in there onto the non-drive. So on there, we're just going to put a little bit of tension in the drive side again, and that'll bring the wheel back across. And again, because at the moment we want to be adding as much tension as you can do, I'm not bothering to loosen the spokes that I've tightened because it's not necessarily, I mean, there's still so little tension in there, it's not really worth it. It'll balance itself out later on in the build. So at the moment that's probably as good as it needs to be. I'm just going to see how round it is. So with that, we use the bottom face there, and you should be able to see the gap getting bigger and smaller as the wheel rotates. So you can see it's not quite round by a long shot. So on this one, always attack the low spots first so that you're adding tension into the wheel. There's no point letting tension out at the moment because there's not enough to get away with really. So again, find the peak of any dips, and you're working in pairs, one from each side of the spoke and one from each side of the hub. And again, this one's particularly loose, so I'm just going to put an extra couple of little winds on there. It may be that the thread wasn't quite cut evenly, so as I say, it's not so important. Oh, there we go, there was a little twitch from the back EMF. So again, that's the worst of the dip there. It's not made a noise, but you get used to seeing where these things are. So again, it's a full revolution on both spokes. Adjust it out just so you get it a bit closer. So again, that's the low spot there. So again, if I use the hotkey, those are starting to get a little bit of tension in now, which is nice. It's not always a guarantee that it's going to get better to start with either. But obviously if you're halfway, you know, if you're starting to put massive amounts of tension in and it's still going wrong, then obviously it's worth taking a step back and just double checking what you're doing. But at the beginning, because there's so little tension, small adjustments will make quite a large effect. Once again, while you're truing a wheel, you'll also bring it out of round, and every time you make a wheel round, you'll bring it out of true, simply because you're disturbing the balance of the tension. So every time you do one, you've got to double check the other to make sure that you haven't thrown it out too far. It's now getting much better. That's the lowest point there, that's at the valve file. So, again, that was very, very loose. Give it an extra couple of winds. That one's nice and tight, so we'll just give that the one wind. So you need to use all your senses, so sound, touch and sight. If you're just relying on seeing what's going on, you're not guaranteed to get a good wheel, because effectively you could, just by sound, hear where the peaks are. So that's there, that's right on the join, and that'll actually be more accurate than trying to visually see what's going on. Again, experience really does come more into it when you're doing that sort of work, but that's no bother. So let's just do these ones. So that's the last bit there. That's the middle of it. And again, sometimes it's easier not to try and look at it, because you won't necessarily find the middle by visual aids. You can hear more what's going on than see. So at the moment the wheel's very, very round. It's just not true. But it's harder to get it round than it is to get it true, so get it round first, and then you can concentrate on getting it true. Excellent. Cool. So now that we've done that, just bring it back up to the side, and we'll hopefully get a nice amount of tension in there. So you can see there, from where I've been making it round, it's more or less true, but we've got one big buckle where the peak of it is there. So again, you can see there's tension on that side, although that spoke's obviously still a little bit loose, and that's the loose one which we now need to tighten up. Obviously, if you have odd loose spokes like that, as I say, it's not necessarily due to the fact that the rim's particularly poor, or you've not necessarily missed a spoke when you've been truing it. It could simply be that there's a little less thread wound onto that one if you've missed the cutting section of the spoke machine or something like that. So again, let's just crack on for a minute. So again, you want to try and put the tension into the loosest ones in the area you want, so that will have the greatest effect. So on this case, that is dead centre, so you've got to do that spoke. So that's a full turn on there. That's just a half turn on each one there. So let's tighten up the non-drive for a second. Unfortunately, there's no set time scale as far as how long it will take you to build a wheel. You can obviously draw an average over the course of several wheel builds, but depending on the quality and the consistency of the product you're working with, some may take you half as long as others, even though you're using exactly the same components. If the consistency's not there, on some of them you can struggle, and others will just fall straight into place. So that's the wrong side, idiot boy. That was far too much of that one.
This is Jonas Rathman. If you love Chris Malinchak, this guy is related creatively to that artist. This is bringing you down. It's the sound of summer 2013.
This is the future of music. Welcome to the future of music. Are you ready? Jesteście gotowi?
So now, although there's not very much tension in the wheel, it's very round and very true. So now you've got the basis of building the tension into a wheel without worrying about, well, it's got a massive buckle over here, but we'll just tension everything down. You've got a straight round wheel, you can now evenly tension the whole thing, and it shouldn't throw out too many odd buckles and dips and stuff in the wheel build. So as well, as you're going round the wheel and as you're putting in layers of tension, again, start at the valve hole, just find the location down there, and just give each pair of crossing spokes a little squeeze, and what that'll do is it will just distribute the tension that you've built up into the spokes and settle them down into the rim and the hub. And what you'll probably find now, if you look back on there, yeah, we've now got, again, just by doing that, we've now got another buckled wheel that isn't quite round or true, just by tensioning the spokes. And again, it just distributes everything around the rim more accurately. So every time you put a full round of tension in, we'll be stressing the wheel off, which again just lets the spokes settle down properly. If they're twisted, it will let them become untwisted and settled properly. So if you've ever bought a bike wheel and the first time you ride the bike you hear a lot of twanging and crunching noises coming out of the wheels, that's because all those spokes from where they've been machine built have not been stressed off and they're not resting as they should be, and that's the spokes all just pinging back into a true straight line. And then of course you spin that brand new wheel on your brand new bike and it's all of a sudden buckled, purely because they don't spend the time to give you the attention to detail and actually, you know, work the wheel round and distribute everything properly. So again, with the Falco stuff for the time being, everything will be handmade to order, unless of course the supplier or dealer you're buying from is buying them in a kit form, just the bare hubs and doing it themselves. Yeah, so I was going to carry on with this for a while and see if we can get it somewhere a little bit closer to finished. So again, what's worth doing at this stage as well, once you've got it to a good consistency of roundness and trueness, is to check the dish of the wheel. So using a dishing tool, this basically measures where the rim is in relation to the frame contact points on the hub. So you offer that up against the rim, helps if you have it adjusted of course. So that goes up against the rim surface, and this little tab here you offer up to the contact point on the end of the axle there that's going to be sat in the frame. Tighten it up, and if we just go around to the other side of the wheel, just need to upskirt, and you offer that up against that side, and that's actually dead centre dished without even, you know, without consciously thinking about it, because you've got the right length spokes and everything's made specifically for this setup. It's very easy to get the wheel into a good condition without having to work yourself harder than you actually have to. So the preparation and the attention to detail at this stage can save you, half an hour or an hour per wheel for having to then correct mistakes that you've missed later on in the build. So at the moment that's pretty round and pretty true. So what I'm going to do now is just put a whole round of tension on all the spokes equally. So what I'll be doing is putting a full rotation on each individual spoke, which will just bring the wheel to a slightly more solid state, and again we'll just show up any irregularities in spoke tension and rim quality, etc., as well as just getting the wheel to be closer to a finished state of tension as well.
We also have Josh, who did the interview this evening before we went to air. Scaly's 30 minutes from 8 to 8:30 dedicated to that interview. We told in detail about some of the trial simulations and ultimate successes.
So all you're feeling pretty tight.
Correct, yeah. And again, when you're going round and you're putting that first bit of tension in like this, you can see straight away that you've got the right length spokes. Ideally, Okay, in this case, we're about a millimetre too long. You can just see the end of the spoke coming proud of the nipple there. What you really want to have is the end of the spoke level with the end of that dip in there as the longest you want it to be. Obviously, as far as being too short, if you can see thread coming out of the nipple on the inside of the wheel, so if you can see thread coming from this side, you know you've made the spoke far too short. So you want to see no thread, but at the same time you don't want to see any coming out of the top of the nipple. So we're going to be more or less bang on as far as overall length once we're actually up to tension. We probably won't need to do much more than another full rotation on all the nipples to have it in a good enough tension to ride for several thousand miles.
So when would you need to re-true the wheel? Or at what point of time do you realize that the wheel needs to be re-trued or brought back in the shop?
Okay, the first telltale sign is if you're running a rim brake, unless you've not balanced the brake properly, you'll find that you'll have instances where you're riding along and you'll have uneven braking. So as you put the brake on, you'll have a very grabby feel to the brake, or if it's loose enough or buckled enough, you'll actually feel the bike squirming underneath you. They're the kind of physical, obvious things. If you're riding along, you suddenly notice, oh, this doesn't quite feel right. They're the things to look out for. Obviously, if the tyre's going absolutely mad all over the frame, your brakes are rubbing inconsistently, that'll be a sign that the rim is buckled. If it's just that the spoke tension has gone too low, so for argument's sake, you find a spoke like this in the middle of your wheel, that's either because that side of the wheel hasn't been tensioned enough and that one's rattled loose, in which case obviously you need to take it back to a bike shop, or if you're handy enough with a spoke key, you can sort out that one spoke yourself and re-true the wheel. But yeah, every couple of weeks, every month, if you're using the bike regularly, just grip a pair of spokes, and if you get any kind of crossing movement like that, your spokes are too loose. If you wanted to go about it in a more structured way, you could take it to a bike shop once every 6 months, which is certainly recommendable anyway, to have a technician just check the wheel's true. But you can do a visual check yourself by spinning the wheel with the bike off the ground and just having a marker against the rim surface to see how much play you have, or by just squeezing the spokes together. If you get a massive amount of movement out of any of them, it's too loose. I mean, even that there at the moment is too loose, whereas on the drive side, that would be the ideal tension for the non-drive spokes once we're finished. But even that for a drive side is a little bit too loose.
So are most of the bike shops equipped to true a wheel with a Falco hub?
Any bike shop should be able to do this. As I say, they're standard spokes, they're standard rims. The only difference is you've got a larger than normal diameter flange. So effectively, it's the same principles. If anything, it's easier to true one of these wheels because there's a shorter distance between the hub flange and the rim. So although you'll probably get a bit of a look from the mechanic at the bike shop, or the owner will be a bit, not sure about that. If they do any wheel truing for their normal customers, they'll be more than able to handle this. They won't necessarily need to take it out of the bike to true the wheel if you just want to have a quick adjustment made, although it is obviously highly recommended to have it trued in a situation such as this for the best results possible. However, obviously with the quality of our wheel builds, we are hoping that you shouldn't need to. It should just be a once or twice a yearly check that the spokes are still under tension, and that should be all you have to do to it. Obviously there are exceptions to the cause, just due to the terrain you're riding on, all that kind of thing. But yes, most people who are confident in a workshop should be able to true a wheel of this type without any fuss or pain.
So what would you estimate that if you build the wheel, how many miles will it last before needing truing?
If you're not riding the bike harshly, and by that I mean doing jumps, taking the bike off-roading, or riding through massive potholes, you shouldn't need to true your wheels ever. Ultimately, if your wheels are built properly, you should never have to true your wheels ever. It's that simple. However, obviously, due to the environment that we live in, obviously there are potholes, there are people who do want to ride off-road, which we thoroughly encourage, and due to that you will get vibration going through the spokes, you'll get a lot of compression of the rim, which will eventually slacken the spokes off. So It will need to happen at some point, without a doubt, but if you run a disc brake wheel, because you're not wearing the rim brake surface of the rim, you shouldn't ever need to worry about deteriorating the rim as far as that wearing out. In which case, you know, you should be able to get sort of 10 to 20,000 miles out of a wheel, provided you've got good enough quality spokes. But again, you know, for general bikes, it really is dependent on whether you're running rim brakes or disc brakes. If you're riding in the wet heavily and you're using rim brakes, of course, your rim is not going to last as long as if you only ride in the dry weather and you're riding a disc brake. It's simple things like that can obviously have a drastic effect on how long your wheel will last through general riding.
And what kind of rim are you using in this build, and what kind of spokes are you using?
Okay, we're using a plain gauge stainless steel spoke. The reason we use the plain gauge one is so that we can cut these down to suit any wheel build. If someone comes in for a spare, we can simply chop them a spoke at any length without having to worry about the thinning section of a double butted spoke. The stainless steel, so there's no corrosion. The nipples are made of brass, so again there shouldn't be any corrosion there. The rim we're using is one of our own branded rims that we get made in Germany, so it's got a CNC sidewall which gives you a really good braking surface with a brake wear indicator as well. As soon as that black line runs out or wears out, change the rim for, you know, full safety. And obviously with our rim as well, we actually have the rim surface dimpled in the direction of the spoke travel, so that there's not anywhere near as much stress on the exit point of the rim on the nipple heads, so that again it should encourage a much longer lasting lifespan of both the rim, the spokes and the hub combined. Obviously you can build the wheel if you don't wish to have a dimpled rim with a standard rim, but it wouldn't last as long on average than a dimpled rim, purely on that basis if you're putting a lot more stress through the nipple at the top of the spoke.
All right.
Cool. So what we need to do... loose one, lovely. Brilliant, that's much better.
Through the next hour, everyone seems to be loving this one right now, so I had to kick off with it. Rusty Slasher.
So now you're listening to the...
That's correct, yeah, so that's the middle of the dip on the rim surface, which indicates that these two spokes need to be tightened. So if you're trying to pull the rim in towards the wheel, you tighten in pairs across the dip. So in this case we're doing half a turn on each one. And again, the reason you do half a turn is so that you minimise the impact of over adjustment. If you've only done half a turn, you know that if you spin the wheel back to that point, which now it's more or less round at that point, you can undo your work nice and easily. So again, I'm just going to find the next one. That's there. So in this case, the centre is roughly on that spoke there. So it really is just a matter of picking which one around it has the least amount of tension, rather than trying to stress out another one under higher tension. So now we've got a bit of a dip in the rim where it's raised in. So what we do on these occasions is, these are two very tight spokes. We'll do half a turn of loosening them off in pairs, which will now bring the rim, relax the rim back outwards. So as we turn around, already you can see there was a bit of an improvement there. It is now just finding the rest of the bad eggs. So the dips inwards are slightly harder to find the epicenter of, by the virtue of there's no noise. So it's just a bit more going by what you know. That's probably going to be a good time to just de-stress the wheel. That's going to be as good as it gets, I think, without just really knows massively. So that's so half a turn in there. Half a turn in there. And we're just moving that dip around the rim a little bit now. Much better. Cool. So I'm now going to do the first de-stress of the wheel. So what we do for that, obviously undo your hub nut, just holding it in there. Open up the stand, and what we use, I'll bring this over here, is a piece of carpet and a wooden block. If I have it the right way around. So the idea behind this is to be able to put pressure on the rim and the hub and the axle without, obviously we have a concrete floor, without damaging threads or damaging rim surface. So again, obviously be careful of crushing the power cable. Rim is resting on the carpet, axle end is resting on the block of wood, and you're just putting a reasonable amount of pressure on the rim just so you can feel it deflect. And you go around a couple of times just to make sure that you can't hear any more spokes pinging. Flip the wheel over, and the same again on that side. Wonderful. So, now we'll see what damage we've got. So each time you do that, you're settling the spokes down, you're redistributing the stresses in the spokes. What you should eventually find is that when the wheel's ready, every time you do a stressing off, the wheel will not become buckled. That's when you know you've got an evenly tensioned wheel, everything's balanced properly, and you've got the ample.
So this is that possible in machines where you are spoking?
If you've got a good enough quality machine to do it, then yes, but you've got to have the machine set to do it. So with a lot of mass-produced wheels, there's simply not the time or the need to actually do it. A wheel tolerance out of the factory, generally speaking, is 1 millimetre of buckle side to side, and the same again in the up and down or circularity of the wheel. Bad English, terrible. So as far as those tolerances go, most of the wheels you buy off the shelf will be within that. But obviously, as far as we're concerned, that's rubbish. You just get it as straight and as true as you possibly can do without compromising the strength and the stability of the wheel. So, yeah, so with this one, after giving it a bit of a stress off, let's just make sure it's tightened down. So it's wonderful. So we now go back and see what's happened. So again, that's given it a lot more side-to-side buckle there, although the roundness has stayed more or less the same. So we know we're getting more even in the overall roundness. It's now just balancing out the buckle side to side. So that's the peak there. And again, at this stage, we're just doing half-turn adjustments again, just to make sure that you don't go over the top. building wheels is a purely balancing act. But you're balancing it between 36 points of contact.
That's a lot of balancing.
It really is. It'd be a very nice way of de-stressing over the course of a day. You can put all your stress into the wheel. You can go home feeling rather relaxed. Especially if it's one of your own, then you can go and ride the hell out of it and really abuse it, which is lovely. There you go, that's now pretty much perfectly round,
That is quite amazing.
perfectly true. And now all that's really requiring on that is one, just to check the dish hasn't been moved across through tensioning it and stressing it off. And then I think realistically in this wheel, there still needs to be another full tensioning going round of at least another half a turn, just to get the remainder of that slack out of there. Again, the main reason that we need this side to be as taut as it can physically be, realistically, is because of the distance between the flanges. So the thinner the distance is between these flanges, the greater the distance. Well, not necessarily true of all cases, but in our case here, because it's so close, you're trying to get that dish all the way over here. These spokes are more or less straight, whereas these ones obviously have a lot more angle on them coming out of here. So you get a lot less tension in these spokes with the same amount of force as you do on there. So you can see the difference quite clearly between the amount of movement you get through those spokes and the amount of movement you get through there.
Yeah, these are a little loose, these are a little tight.
So again, for certain customers, if you wish to go down the route, if you want to have a even stronger wheel, there is a practice known as soldering and wrapping spokes. And what you do, back in the day before good quality rims were available and good quality hubs and spokes, mechanics used to cross the spokes as normal, and on the last intersection of the spoke they'd actually wrap a very fine wire around that crossing with a blowtorch. They'd just heat it up very gently and actually solder that wire across that crossing, which means that you get an even larger flange diameter. So obviously if people are willing to spend or want to spend the extra time and money to have that done, you can actually increase the stiffness and longevity of your wheel again by soldering and wrapping the last intersection of the only intersection obviously we have on a single cross rim wheel build, and it will make the spokes and wheel last considerably longer again. So let's just double check the dish quickly, see if that's moved. So you might have come across it so slightly. That is near as damn it perfect. Wonderful. And, probably do a quarter of a turn onto the non-drive side just to get it absolutely spot on. For the moment we'll leave that until the very end. So let's just do another half turn around the whole wheel and see if that brings us up to a final tension. So yeah, they're feeling nice and tight now. And again, the beauty of not having the eyelets on here and having the dimpled rim means that as you put the tension in, there's much less likelihood of the nipples turning through vibration, because you get a slightly better bit of stiction on the nipples. Although of course the only downside to that is it doesn't spread the load as evenly, but there's always that compromise, unfortunately. So I reckon we could probably get another half turn after this, but we'll see how it goes. Let's get to the limit there. That's much more like it. Fantastic. So, again, just go around, see what effect that's had on the trueness. So you can see it's had probably a quarter of a mil, half mil buckle interjected there. So that's there. If we just take that out, stress the wheel again. Wonderful. So,
I will be back next month because I'm covering beat takes whilst you come.
no.
So,
Yeah,
all right. So we are distributing the tension.
correct.
Okay.
So, I'll explain later. Indeed. I can watch the video. Because on the internet.
Yes.
It will be, unfortunately. I'll have an option to watch it back and cringe inside. So what have you done? So basically, as you build the wheel up, as you're turning the nipples, it also slightly turns the spoke as well.
I'm with you, so you're just releasing the tension.
That's it, and it lets them spin to the correct position, and it redistributes the tension that you're putting in. So you can find if you've trued the wheel and you've got the spokes as tight as you can possibly make them, and then you stress the wheel off, one, it will redistribute what tension you've put in it. That's pretty much done, it's wicked.
Can I see it?
And also, when you then go back to truing it, because the nipples and the spoke heads have sat down more comfortably, you can then wind in more tension without having to just get a scaffold pole on each nipple and crack on again. So realistically, we've probably got another half turn to do on each spoke, and we're going to be cooking on gas. So,
You're gonna cook the wheel on the gas?
oh yes, definitely. At least gas mark 6, half an hour, job done. Just let it rest for 5 minutes afterwards.
So now you're turning. Why you are turning half a turn when you know the wheel is totally true?
Basically, it's totally true, but the tension isn't tight enough yet to make it last any decent length of time. As it stands at the moment, I mean that's reasonably good tension, but we can get that much better than that. So we go in half turn increments so that we know exactly how much we've got. So if I was trying to do a full turn on all of these spokes in one go to get the final tension, you'll find that you'll get halfway around the wheel and it'd be impossible to turn the last half of the spokes, simply because you've put far too much tension in one area and the rest of the spokes will just take it out. So if you could work in half turn increments, one, it keeps the consistency of the build more accurate. You're not dumping a lot of tension in one area as you're going round, it's much more even. And it allows a little bit more control as well. So if you get part way around the wheel and you physically can't put any more tension in, it means that you can go back, undo that half turn, and you haven't destroyed the equilibrium. Remember your start position. Always work from the valve hole.
Oh, good lad.
Oh yes.
Keep it simple.
Exactly that. Simple is the key. Without a doubt. Yeah, if you try and make any complicated patterns like you would do if you're putting an engine head gasket on where you've got to put the bolts up in a certain way. I mean, technically, if you had the patience and the ability to do that with this, you probably could build it even more well balanced.
Yeah.
But at the end of the day, if you're stressing the wheel off after each successive full tension all the way around, you will effectively reinstate the balance and everything. So already that's the non-drive side, which are now in a much better condition, and the drive side are really nice and tight and rigid, so that'll be much better. So again, I've done a completion there on a full wind round, so I'll now take the wheel off again. I won't bother checking the trueness at this stage because I'm going to have to true it again anyway. So it's pretty much straight to begin with. We'll just see what that extra tension has done as well. So you should be able to hear the crunching. There you go. That's all your spokes straightening out. So again, when you buy a new bike, if you hear that noise coming from a wheel, it means they haven't built the wheel properly. Well, in my opinion anyway, because I haven't stressed the spokes off. So you ride your bike for 5 miles, or even a quarter mile down the road, and your wheels will be buckled. So again, that's, in theory, strong enough to take my full body weight.
That's incredible, man.
That's when you know you've got a wheel that's up to tension and ready to ride. In theory, you should be able to do that with a 700c wheel as well, and not have it fold underneath you. And that's the test of a true wheel build. But even on 26-inch, it's not very often you can attest to doing that and not have to worry about it breaking. So again, even though I've stood on that, there's about 1 millimetre of buckle there, which is basically down to the tension. So we'll true that up, get that sorted out, and that'll be ready to ride.
Okay.
When I retrieved moves, snap the flange off.
Yeah, it wasn't our brightest moment, was it?
Do you take sugar or
Yes, please.
milk?
Both.
Both. 1 or 2 lumps?
2 each, please. I guess lump, yeah, 2 is good.
I'll tell you what, on the plus side, after worrying about these nipples, the quality is not half bad. It's just painful to use the tool. So I have to get one of those.
So your
made up.
coffee's here, Rakesh.
Thank you so much.
You're on your yacht or whatever it's called. Yeah, you were over here. Cup of tea.
Wow, that wheels look really good.
Certainly getting there. I mean, that would normally pass any inspection as far as a pre-made wheel, but unfortunately I know I can get it better than that.
Do you want 2 coffee, Bob?
Can I have coffee, please?
Yeah. Sugar?
1 and milk, please. Cool, right then, so we're on. I mean, there's more movement in the wheel truing stand than the actual wheel itself. So
That looks pretty good to me.
be the last one. Just a quarter turn on there. I think
Wow.
that's a pretty straight wheel. Like I say, if time was no object, I'd spend even more time just getting that even straighter than that. The roundness would be fine as well. Right, so just do a final stress off.
So can you have Corin cut me a set of spokes for 700C and 26, which I can take with me?
I mean, what they'll be. I mean, as far as cutting, we'll still throw it out ever so slightly. I mean, it's probably not going to be much.
Excuse me,
but-
Corin.
Wonderful.
So this should be the last.
This should be it. Yeah, this is just basically to check that everything's finally settled. There you go. Hasn't moved at all.
That's lovely.
One round wheel.
All done?
Yeah, all done. Ready to go. So get it laced up, get it rim taped, tired,